everyone, welcome back to Math Room by Teacher Joanne. In this video, we're going to have another lesson in basic calculus, and the focus is all about the limit theorems. What are the learning objectives? At the end of the lesson, you should be able to illustrate the limit laws or theorems and apply the limit laws and evaluating the limit of algebraic functions, polynomial, rational, and radical. In the previous videos, we showed how limits can be determined with the use of table of values or graph of a function. And others may think of this question: should we always need to construct a table of values or draw the graph of the function to find the limit? The answer is no. Doing either of the mentioned ways might be tedious to do or difficult for some, and so the limit theorems will help us find the limit easier. So what are limit theorems? These theorems help to find the limit of a function without sketching its graph or constructing the table of values. These theorems will enable to directly evaluate limit following the 8 basic theorems. So let's discuss each limit theorem. Theorem number 1, limit of a constant. The limit of a constant is the constant itself. If k is any constant, then the limit of k as x approaches c is equal to k. Here are some of the examples. Let's say the limit of negative 2.5 as x approaches 3 is equal to negative 2.5. It is the constant itself. Another example, the limit of 2021 as x approaches negative 9 is equal to 2021. Theorem number 2. Limit of an identity. The limit of x as x approaches c is equal to c. This may be thought of a substitution law because x is simply substituted by c. Here are the following examples. Let's say the limit of x as x approaches 0.04 is equal to 0.04. Just simply substitute the value to x. Second example, the limit of x as x approaches negative 100 is equal to negative 100. Theorem number 3. Limit of a constant multiple. The limit of a multiple of a function is simply that multiple of the limit of the function. If we have the limit of k, the constant, times the function as x approaches c, this is simply equal to the constant times the limit of the function as x approaches c. So in simplifying, we will just simply multiply the constant and the limit L. Here is the example. If the limit of the function f of x as x approaches c is equal to 5, and if we're looking for the limit of negative 9 times the function as x approaches c, this is just equal to the negative 9 times the limit of f of x as x approaches c. Here, the limit of f of x as x approaches c is provided, which is equal to 5. We'll just simply multiply negative 9 and positive 5, which is the limit. Then it is equal to negative 45. So this is the answer. Theorem number 4. Limit of a sum or difference. The limit of a sum or difference of functions is just simply the sum or difference of the limits of the individual functions. So if we have this, we'll just simply get the limit of each function, then we just simply add or subtract depending on the given. Here is our example. If the limit of f of x as x approaches c is equal to negative 8, and the limit of g of x as x approaches c is equal to 5, then if we're asked to find the sum of the limits, we'll just simply add negative 8 and 5, and the answer is negative 3. And if we are looking for the difference of the limits, we have negative 8 minus 5. This gives us negative 13. Theorem number 5. Limit of a multiplication. This is similar to the addition or subtraction theorem. We will just simply replace the symbol to a multiplication symbol, the times symbol. So we'll just simply get the limit of each function, then we multiply. Here is the example. If the limit of the function f of x is negative 8 as x approaches c, and the limit of g of x as x approaches c is equal to 5, if we are asked to find the product, we will just simply multiply the limits and then the answer is negative 40. Theorem number 6, limit of a division. This says that the limit of a quotient of functions f of x and g of x is equal to the quotient of the limits of the individual functions, provided that the limit of the denominator is not equal to 0. If in case the limit of the denominator or g of x is equal to 0, which is not allowed in the denominator, then automatically the limit does not exist. Here is the example. Given the same values, the limit of f of x and the limit of g of x, we are asked to find the quotient or the limit of a division. We have negative 8 over 5, which is equal to negative 8/5. So this is the limit of a division. Theorem number 7, limit of a power. This theorem states that the limit of an integer power p of a function is just equal to the power of the limit of the function. So this one is equal to the limit raised to the power of p. Let's say the limit of the function x as x approaches c is equal to 3. Then we are asked to find the limit of f of x raised to the power of negative 2 as x approaches c. This can be written in the form of limit of f of x as x approaches c raised to the power of negative 2. In this case, since the limit is 3, we will just simply raise 3 to negative 2, and the answer is positive 1 over 9. So this is the limit. Theorem number 8, limit of radical or root. This theorem states that if n is a positive integer, then the limit of nth root of a function is just equal to the nth root of the limit of the function, provided that the nth root of the limit is a real number. Thus, it is important to keep in mind that if n is even, then the limit must be positive. Because once that the limit is negative, we cannot take the even root of a negative number. So here is the example. If the limit of the function f of x as x approaches c is equal to 12, and we are asked to find the limit of the square root of f of x as x approaches c, this can be written in this form, square root of the limit of f of x as x approaches c. In this case, to find the value, we'll just simply replace this one with the limit value, which is 12, so we have the square root of 12. Then we need to simplify this value by getting the factors of 12, which are 4 and 3, and the square root of 4 is 2, then we have 2 square root of 3. After discussing the 8 theorems that are used to find the limit of a function, this time you need to check your own understanding. Given the limit values of the 3 functions f of x, g of x, and h of x, kindly compute for the following limits. You may pause the video to answer these problems. Let us now check your work. First, the answer is 11. Second, the answer is negative 3/2. Third, the limit is negative 8. Fourth, the limit is positive 3. Fifth, the limit is 7. And last, the limit is negative 3/8. Were you able to answer all of these items correctly? If yes, great job. Here are the important things that you need to remember. Limit theorems help to find the limit of a function without sketching the graph or constructing a table of values. This will enable to directly evaluate limits following the 8 basic theorems, which are the limit of a constant, limit of an identity, a constant multiple, sum or difference, multiplication, division, power, radical, or root. This is the end of our discussion about the limit theorems. I hope you have learned a lot from this video. Thanks for watching. Please don't forget to like, comment, and share this video. And if you're new to my channel, please don't forget to subscribe and click on the notification bell to be updated. Bye everyone! See you on our next video.